Hello, my History 125 students. This is Professor Donald Earl Collins coming to you from a slightly different location and somewhere in the place in which I live. Um, so, hi. This is week 7 for the course, and week 7 involves talking about the advent of modernity as far as we understand it today in terms of electricity, household appliances, um, the change of life to the modern, right? Where the modern home, modern society is fully taking shape, right? Transit systems and electrical power, electrical grids and alternating current and all of those other things. And so I'll talk to you a little bit about that in this video today. But I also want to go over very, very briefly the week 6 discussion and talk about the week 7 assignment as well, the new week 7 assignment for this course as well. So first, the week 6 discussion. I've taught this course something like about 8 or 9 times over the last 4 or 5 years, and week 6 is always the big week in terms of how much of what people learn in the course comes to bear. And typically, this is the week where students do the best job, week 6 and week 7. And once again, that's been the case, which is very good. The only thing that comes up every once in a while, doesn't come with every course. Some courses it does, some sections of this course it does, other sections students don't even think of it, is where people say, but eugenics isn't entirely a wrong thing to do, that in fact, um, can be a good thing, and that, eugenics isn't bad in and of itself. First of all, eugenics is not a science, all right? It's not scientific. Eugenics is literally based out of someone's racism or racial bias. However, that's defined. That's not just black, white. That can be um, white Anglo-Saxon Protestant versus Slav. It can be German versus Jew. It can be abled versus disabled. They're all forms of some sort of racism. That is, there are some humans that are better than others, and because some humans are technically superior to others as far as that group's concerned, those other humans are expendable. That is the most expansive, it might be a more expansive version of or a definition of racism than you're normally used to, but it's still racism. It's racism based on someone's abilities, which, and ableism is actually a form of that. It's racism based on skin color, based on lineage and how much of your lineage is quote unquote pure, those kinds of things. So to argue that eugenics isn't bad, breeding is not eugenics. Breeding is just breeding, right? It's called animal husbandry. It's called grafting plants. It's not eugenics in any formal sense. There's another term for this, which would be genetic manipulation, but keep in mind, no one had seen the structure of any DNA prior to 1954, right? We knew what genes were, they were predicted, but no one had literally seen any of these under electron microscope until the 1950s. So it's kind of hard to argue about eugenics being a science. It's basically an ethical decision based on very loosely based on science. It is based on science, but it's not science per se. There's no scientific institutional eugenics in the field, at least not in modern times, precisely because it's not truly a science. So keep that in mind. For some of you who gave answers trying to defend eugenics in terms of being used for humanity, no. Okay. As for the week 7 bibliography assignment, I've taken a closer look at it for those of you who were with me in video last week. And not much really is different than what I already said to you, right? I just re-looked at it and said, what they're giving you as instructions is the same thing I would give you, maybe not as specific, but you're finding 5 sources. In my case, you don't have to write the minimum of 150 words per website that deals with a particular topic. There's nothing in the instructions that say that you have to do a particular technology and scientific breakthrough. You can just look at 5 random websites that deal with science and technology and go from there, theoretically. It might help if you narrow it down, though, and that's my suggestion. Strong, strong suggestion. I can't require it. If you decide that you just want to do 5 random scientific websites, you want to do Scientific America, you want to do something else, fine, you can do that. But it would be easier for you and easier for me as your instructor and person who's assigning grades to these things if you actually did try to find a theme similar to what we did for the week 4 assignment. So if you wanted to do power tools, you could do power tools. If you wanted to do agricultural equipment and how it's changed over time, you could do that. If you wanted to do transit systems and how transit systems have changed since the 1800s to now, you could do that. There, literally the moon's the limit here. You can go out in the universe and try to find as much as possible, but you want it to have some theme to it so that you can do, so that when you write about these 5 websites, it's just not just completely and utterly random. Oh, here's a site, where you get to use medieval, battle axes and lances and swords, and then here's the next site talking about oil tankers. I mean, you some consistency would be helpful for you and helpful for me as well. There's a whole list of no type websites to look at. The one thing that the instructions don't list is a blog. Blogs are also part of this. Most people's blogs aren't by experts. So unless it's an expert, say it's someone who has expertise on psychological epidemiology and how the tools for doing that have changed in terms of the science since the end of the 19th century, and you find a site on that, or find a blog on that that happens to be from a world-renowned person in the field, yeah, you can use that blog, but you're probably not going to come across too many of those. So for the most part, you shouldn't be using a blog. The other thing is, and the instructions say use Chicago style. There is no singular format in Chicago style for citing, for writing a bibliographic reference for a web source, for a website. There isn't one. So keep that in mind too. So I'm going to give you leeway here. If you do something that looks more or less like Chicago style in that regard, you're going to be okay, right? But some obvious things that look more like APA in terms of capitalization and initialing the first and middle names of authors type of thing. If I see any of that, then I'll know that you're not using Chicago style. But beyond that, you should be fine. So 150 to 250 words, 5 website sources, not web pages, websites. You can use Wikipedia to help you find some of those sites, but I'm okay with you using Wikipedia as a source in the sense that it helped you find those sites, and you can say that in your thing, right? So I'll make a mild exception for that. And I'm trying to think, is there anything else? So try to keep as close to a theme as you possibly can, right? Don't go completely random. And 150 to 250 words, Chicago style, as close as you can get to something that looks like Chicago style is fine. Don't expect it to be perfect because there is no one way to cite the website in Chicago style. So please put a heading at the top of your document. It's not enough to name the document and the file name with your name in it. You need to have a heading, so that in case anything were to happen to it, I know who's documented it, right? If I wanted to print it out, if I wanted to, save it on my hard drive, which I oftentimes do, right, for stuff that I'm grading, put your name on it. So that's it for that. So let's talk a bit about week 7. Week 7 is the week that we talk about the period between the second half of the 19th century up to about the time most of us, if not born, were about, how our parents were alive by then, 1980 or so, roughly 1980. That's the period of time we're in this week. And this is the week where true modernity shows up. The advent of the use of electricity to help run our daily lives is key to everything that we're talking about for this week. The developing of electronics, the use of radio, the making of things like atomic bombs. You need electrical equipment for it all. Running a car requires electrical equipment because you need a battery to help start the car. Um, running a Lionel train set requires electricity. You're not using steam to power the locomotive. You're actually using electricity for that. Um, Tanks even require a battery, right? Everything that we run in our society these days requires direct current or alternating current in terms of electricity. And it's the importance of people like Nikolai Tesla and Thomas Alva Edison that bring us to this period of time known as the electrical age, electronic age, right? You don't have, there's no information age without electricity. There's no internet without electricity. There's no ability for me to do what I'm doing right now without electricity. Um, the very fact that nights aren't as dangerous as they used to be, despite what you might think about crime statistics and crime rates, um, we've been in a period since about the early 1880s where people have been able to work at night, walk the streets at night, go to bars and restaurants at night, barring the pandemic, of course, because of electricity. Electricity is really important here. You have some questions to ask you about for the discussion this week about what's a key of development in the period roughly between 1870 and 1980 that basically transformed the lives of everyday people. Not Americans, not Europeans, everybody. The globe. Transformed the globe. And the answer is electricity, right? More than so than anything else. And not the invention of electricity. Electricity already exists. It's a natural phenomenon. It would be like saying you invented frogs. Right? No one invented frogs. They were already here as far as humanity is concerned. So the same thing goes with electricity. You invented electricity, but we discovered scientific principles around how to harness electricity. And that's what happened in the period of the second half of the 19th century. Um, Edison and Tesla are considered essentially the two people who are able to best figure out how to harness this electricity. Edison went with direct current. Tesla went with alternating current in order to step down electricity so that people could use it and it could travel further distances, which is what we use today. Otherwise, there would have to be a power plant in every neighborhood in the United States or in every neighborhood around the world because you wouldn't be able to send out electricity hundreds, if not, or even thousands of miles. Um, and so that's the difference between direct current and alternating current, or AC/DC, as we like to call it these days. So Edison was wrong about that. Yes, the genius of Menlo Park, New Jersey, who had 200 people working for him and a core staff of 8 or 9 people, got something wrong, which shows you that he's not the genius you think he is. He's really smart, to be sure, but when you have an army of people, a small army of people working for you, a battalion of people working for you, not really as smart, but genius. Genius is kind of in the eye of the beholder. I think it's overused personally, but historically, it just shows you what it really took to get this kind of work done. That's one of the other themes of this week, really. If you look at things in the modern period around, um, you know, washing machines, frozen vegetables, the refrigerator trains, um, the electric iron, um, even diapers. It wasn't just people worked on that. Not one person might have had a great idea, but people worked on that. Dow Chemical is an example of people working on stuff to create nylon, synthetic rubber, etc., etc. You know, individuals make discoveries that might help us make small leaps in terms of technological progress and scientific innovation, but it takes an army of people however small or however large, to get that stuff to societies. And it's something that I have had to keep emphasizing throughout the semester because people tend to forget. And now that we're here in more modern terms, people tend to really forget because we have this sense that it's great men, usually white, but great men who are sitting around and one day coming up with ideas whole cloth. And the reality is it's not. It's just individuals who have some ideas, and then they have to test it and make it replicable and, reliable in order to make it that something that you can replicate over and over again, and reliable so that other people can do the same thing that this person did. It takes more than one person to do that. That's the case with electricity. That's the case with pretty much every invention you're going to be talking about in discussion online this week. So what I want you to think about in terms of this week, is not only in terms of the whole issue of collaboration, but also the issue of how so many of these inventions also were used for bad, right? Electricity is the whole reason why we were able to blow ourselves up with nuclear weapons. The whole basis of electricity. What do you think, nuclear fission or nuclear fusion is? It's actually an application of electrical power, and at the atomic level, mind you, but electrical power. It's literally just an extension of the principles of electricity, the principles of thermodynamics, the principles, but at the atomic scale, right? Because without atoms, you can't have electricity. I'm sorry, I took basically the equivalent of a year of physics, of college physics too, so that means I've looked at quantum mechanics. So yeah, and so if you're talking about Einstein, if you're talking about Enrico Fermi, if you're talking about um, Oppenheimer and other people who deal with the atomic and the subatomic, the principles of electricity apply there too. You can't have electricity without atoms. You can't have electricity without having atoms in the right sequence. You can't fuse atoms without a lot of electricity, a lot of energy, at the quantum and at the cosmic scale. And you can't have fission without the ability to split atoms, using neutrons. So all of that is included in understanding the science. But the application of such science in terms of humanity and our frailties and our weaknesses and our general sorts of seven deadly sins kinds of things is also in play here too. While all of this sort of rapid progress is taking place, two world wars occur. Between the two world wars alone, 100 million people die, right? Give or take. Something like 80 million people during World War II and about 20 million people during World War One. Many of those people being civilians. Many of these people because principles of science are being applied to their lives in the form of bombs and carpet bombing of cities across Europe and across Asia, in the form of nuclear weapons in the case of Hiroshima and Nagasaki, and barbed wire and tanks and machine guns, in the case of World War One and trench warfare. Chemical weapons, even biological weapons used during World War One in particular, also in play here. And then with the Cold War, of course, is the great nuclear weapons arms race, where USSR, the former USSR now, but the Soviet Union and the United States build enough nuclear weapons to wipe out every city on the planet and basically wipe out human civilization as we know it, creating a nuclear winter, and possibly wiping out a portion of life in the process. So, don't think about this as just pure progress because, we talk about how the West, and when I say the West, I mean Europe, the US, Canada. The West is this beacon of progress. How much progress can it really be if you're also using these scientific and technological tools to kill each other left and right? Right? So much of that is on the West too. So you can say, oh, everything the West has done is great in terms of science and technology, but you're using computers to basically figure out how to kill each other faster. We're using the biology we've learned to figure out more effective ways of killing off populations in case of war, and sometimes experimenting on people during peacetime in order to figure that out, right? Um, Nuclear weapons, of course. We figured out even neutron bombs so that we don't damage cities but kill people. using those atomic principles as well. So for all of the wonderful things that electricity and the science of physics, particularly quantum physics and quantum mechanics, has brought to the world, astrophysics, rocketry, and the ability to go see other parts of the universe, other parts of our own solar system, leave our planet for the first time and go to the moon, all those things that humankind has been able to do, particularly the West. There are also all these horrible things that have happened in the course of pursuing science and technology without also pursuing the development of a sense of ethics that fit our science, our technology, scientific and technological progress. We're still not there. I mean, obviously, with everything that's going on with the pandemic, everything that's going on in terms of um, racial justice, misogyny, homophobia, whatever the isms that we seem to have that we're still plagued with. We're still quite not there. We have not caught up with the technology and science that we, as a species, have birthed in the last couple hundred years.